Hi everyone, welcome to the video. In this video, we're going to solve check for children sum property in a binary tree. So, as expected, we will be given a binary tree, and we will have to check whether a particular node has sum equal to their child node. Whether a particular node has whether all the nodes in the binary tree have sum equal to their child nodes. So, see for example one. Take the root. Root has value 35 and it has two children, left and right. Left has 20 and right has 15. Sum it 20 and 15, which will yield us 35. And this sum of children of 35 is also 35. Okay, go one step ahead because you have to check not for one node, not for root, but for all the nodes. Okay, go to 20. Okay, left child. It has two child, 15 and 5. Sum them 20. Is 20 same as the 20? Yes, it is. Well and good. Go to other right child. 15. Okay. Node is 15. It has two child, 10 and 5. 15. Is 15 same as 15? Yes. So all the three nodes have sum equal to their child node. You may talk about the leaf node. You make note because leaf node do not have any children. Okay. So you have to consider the nodes which have children. Okay. Go to example 2. What is value of root? 1. What is value of its child? 4 and 3. Sum 4 and 3, which will yield us 7. Is 7 same as 1? No, it is not. We will return false. Return false. Return 0. Cool. So we do not need to check, go even further. If Because we have to check for each and every node. If even one node fails to match the criteria, if even one node fails to match the criteria, there's no need to go further down. Okay. So I'll be using tree traversal, BFS, breadth first search tree traversal. Okay, so first of all, I will import DQ. Okay, so the basic tenet of this algorithm is, which we are going to apply is, we'll check for the first of all, we'll pick a node of the, okay, from the queue, we'll DQ here, okay, and we will store our sum, okay, now store that particular node sum, go to its left node, calculate its sum, go to its right node, calculate its sum. Okay, well and good. Now add them. Okay, add them. Keep on adding, and at the end, check whether the sum of all of its children, sum of its children, okay, both its children, or if there is one, or there is none, sum of children should be same as that particular node. Sum of children should be same as particular node. Okay, how we will apply it? Let's see. First of all, the base condition: if there is no root, if there is no root, it has no sum and it has no child. Hence, it will always be true. It will always be true. Good. Now we'll create a queue of type DQ. Store the root first of all. Now, traverse in this queue. Traverse in this queue. Pick a node. Pick a node from this queue. Queue dot pop left. Pick a pick a node from this particular queue. Okay. Now create a variable sum of child. Sum of child will be 0 because initially it will have no sum. As we go down further, it's explore its left child, right child, then only we'll be having sum and we will update it. Now, first of all, another condition: if there's no right child and no left child, in that case, we'll always have to move further because it will either be a leaf node. Okay, it will be a leaf node. Okay, and not node dot right. If not node dot left and not node dot right, continue because we have to go ahead. We do not have to stop here. Now, first thing, if there is node left and there is right node, explore one. If not node dot left, cool. Now in q dot append, node dot left. Add this particular node to the queue and store its value in the sum of child. Node dot left dot data. Cool. And do similar thing for right node because we have checked, we have node left node and right node both. So after exploring left node, we'll further explore the right node queue and add it to the queue first of all. dot right and add its value to the sum of child value. Node dot right dot data. Cool. Now the only condition which you need to check is after calculating sum, which is sum of child which you have calculated so far for this particular node is same as the value of this particular node or not. If sum of child and node dot data, what we will apply, we can check it's same or not, but the only condition is we have to check for all the nodes. If any of the node you know goes apart from this particular set structure, it will has to always yield false. So the possibility of getting false is much more than possibility of getting true. In that case, we'll check not equal to. Okay, we have to minimize our computations. So if sum of child is not equal to node dot data, return false, because we have encountered a node whose value is not same as its child's value. Cool. And if at the end we have explored all the nodes in the queue, return false. We have not encountered any situation wherein we'll have to what? We'll have to return false or zero. In that case, we'll return one. Let me compile it and check whether we have arrived at correct solution or not. Okay. Yeah, it did the job and it took very less time. It took very less time. So our algorithm is pretty time efficient. So I hope you learned the concept and enjoyed it. Thank you. Have a nice day.